So in all my years of programming, I've never actually made a multiplayer game before, and since my retro FPS is stuck deep in the content mines right now, for this video, instead of doing any actual productive work on that project, I'm going to try to make a 2D co-op multiplayer wizard game called Sorcery Squad in just 1 week, in C with no game engine, just a couple utilities from the FPS project. Let's get started. So after getting our build system set up and potentially breaking the world record speedrun for a build error, I decided that the first thing that I needed to do to make a multiplayer game was to get a basic client and server up and running to do, multiplayer. Now it had been a while since I'd done any network programming at all, and as per usual, I didn't want to pull in any libraries, but buried deep somewhere in the depths of my brain, I had an idea that there were these two POSIX functions called send and receive, or reciv, for interacting with network sockets that could get the job done for me. So a few man pages later and some further investigation, and will allow me to crack open NeoVim and show you how I got things started. So here we've got a tiny C program that can either act as a client or server depending on the argument passed to it. Well, as soon as we fill in these functions up here. So let's start by writing our server. To get started, first we create a socket, which is just an integer that acts as a handle to some IO stream. Then we tell the system to bind the socket to whatever open port it can find, and then we start waiting to accept a connection from whatever tries to connect. When the server does get a connection, we just receive whatever data is coming down the network pipe, print it out with absolutely zero sanitization, and exit. Probably the world's most basic and insecure server, especially considering it doesn't even properly handle errors, but Clang compiles it happily and without any complaints, and if we run it, it looks like this. Which is very cool and all, but it's not going to do anything until we've written a client for it. So our client code looks a lot like our server code, but instead of binding the socket to any open network port, we tell it to connect to the server on our local machine at a specific port, shovel a nice little hello message to the server down the network socket with a send function, and then we exit too. Now our server has a little friend to talk to, so if we bring it back up, rebuild the program over here and run our client with the correct port, a connection gets opened up, the client says hey to the server, and then both programs exit. And we can see that our server got the message. And while it may seem really simple, that's basically the scaffolding for the netcode for this game. You're probably wondering though how we go from this to a fancy fully networked game with lobbies and real-time player movement and things, and well, that makes two of us, because this is about as far as my network programming knowledge could take me. Before we can figure that out though, this video is sponsored by Brilliant. Brilliant is a free and easy way to learn math, computer science, data science, and well, a bunch of the concepts that I like to talk about on my channel. Brilliant has thousands of different lessons from beginner to advanced, so if you're just starting out programming and want to learn algorithms and data structures, or if you're just dusting off some math skills you haven't used in a while, Brilliant is a great way to learn interactively and at your own pace. As you probably know, math is a huge part of everything that I do, so I've been using Brilliant to brush up on my calculus and linear algebra so that I can keep my programming going smoothly and don't get too confused every time I stumble on some graphics tech research paper with big fancy equations. Even if you don't know where to start, Brilliant can pick out courses for you tailored to your needs. Just take a quick quiz when you get signed up, and Brilliant will match you with lessons depending on what you want to learn and your current skill level. So try out everything that Brilliant has to offer with a free 30-day trial. You can go to brilliant.org/JDH or click the first link in the description. The first 200 people who sign up will also get 20% off an annual premium subscription. So don't hesitate to give it a try, and thanks again to Brilliant for sponsoring this video. So after perusing a couple articles about how real-time game networking is supposed to work and taking all of 3 notes on it, I found that what I wanted to implement was a system where the client and server could send packets of data to each other rather than just text. The packets look something like this. So every message that gets sent would use 1 byte to specify its type, 4 bytes to specify its size, and then have some data which would be the actual payload of the packet. Only problem now though is that once we send the packet bytes on one end of the connection, we need to somehow make sense of them on the other end. So we could manually specify all the serialization code, but since that sounds really time consuming, I decided to bust out the old C macro writing skills, and well, if you know my channel, you can imagine the monstrosity that's about to come up on the screen. So basically, if we just list out all the packet types in this macro, we can feed that macro into this macro, which uses this macro combined with this macro to make a nice list of fields in each packet, which we can then serialize and deserialize from the bytes we read from the network socket, in a loop that kind of looks like this. Makes sense, right? Okay, actually all of this macro stuff is just to spare us manually typing this little bit of code out for each packet, but it's kind of a pain to specify, and this is basically what it generates in the end anyway, but, sometimes I just have to indulge. If you're curious though, there's a link in the description explaining how all this macro garbage actually works. With the packet system set up, everything multi-threaded so that we can run a client and server at the same time, and those two pinging each other back and forth at the speed of light, I wrote a little more code to let the server handle multiple connections for, multiple players. And I also threw in all these functions so that we could send packets back and forth easily on both ends of the connection. And after that, it was finally time to do something else. So what exactly were we building again? Oh, right. Wizard game. So I used SDL to open up a little window here and make it show some pretty colors, and then I yoinked a sprite sheet from an old project of mine and got 10,000 random rotating sprites on the screen to act as a stress test, and then I called it a day. Not too bad for day one, but as there are no signs of wizardry yet, there's still a little ways to go. My goal for day 2 was to get a player moving and synced between the client and server. So to start out, I added our player, which is this thing, just imagine that it looks like a player for now, and I gave it some basic input handling to start moving around. After writing out a player move packet so that the client could send it to the server to tell it when it wants the player to move, here's what that looks like. The little red trailing thing is where the server thinks the client is while it's moving, and there's a tiny bit of lag due to the fixed update rate, but overall, things were looking pretty good. Except when we tried to simulate some lag, which unfortunately is something we'll have to deal with as the laws of physics do kind of prevent this sub 1 millisecond ping that we've been getting when we use a real network at real distances. So to illustrate what's going on here, imagine that you have 200 milliseconds or 1/5 of a second of lag. That is, these ping packets are taking 200 milliseconds to make a round trip from the client to the server and back. What's causing this bug is that if you, the client, try to move the player, you start seeing your player move as soon as you press the move key, but 100 milliseconds later, the server sees that you started moving the player, so it starts moving the player only 100 milliseconds later in time. Now that the player is moving on the server, it sends a packet back to the client saying, hey, this entity moved over here. Only when that packet finally hits the client, it's 200 milliseconds later than when the client actually started moving, and that's what's causing this jump. After reading some articles about how I might be able to fix this, this is where my lack of multiplayer programming experience caught up to me, and I kind of just spent the most of day 2 trying to hack around with client-side prediction and trying to fix this up without much luck, which was very promising for the plan to get this whole thing done in 7 days. So, good planning, me, but unfortunately that was all of day 2. After a good night's sleep though, day 3 started with an epiphany. The entire game is cooperative, that is, there's no player versus player combat, and you really don't care if your friends are hacking. It actually doesn't matter at all what the server thinks about where the players are, so I changed the network architecture to just take whatever the client says about where the player is at face value, and have the client just ignore the server when it tells the player to be somewhere. And with that little hack in here and 2 clients connected to our server, we can see that the lag gets dealt with appropriately and things are about as smooth as they could be. So with networking finally sorted out, I got started on some graphics so that we could stop looking at these ugly little gray squares. Inspired by my old Minecraft video, I went with a system where each sprite can have up to 4 colors specified in hexadecimal as RGB tuples, where each red, green, or blue component can range from 0 to 5 for a total of 216 colors, which lets us color sprites programmatically so the same sprite can easily be reused by just recoloring things at runtime. So using the new graphic system, I cooked up some walls, lava, and new floors, then replaced our little gray square with this cute little animated guy. After adding in some basic collision and bounding boxes for tiles and entities, and defining some packets for the server to send data about the level layout to each client, by the end of day 3 I had 2 players running around in the same level, which I would definitely consider a success compared to the disaster that was day 2. In any case, the whole game in 1 week idea was back on track. Day 4 started with me burning some precious work hours finding various long-standing bugs in my utilities library, the highlights being the left and right direction being swapped, the direction rotation being wrong, and the intercardinal direction to string function also being wrong, which made debugging all of this a pain. Which is I guess why you write tests, or you just use other people's code. With the first few hours lost to finding those bugs, I got started on building out the UI, which would be needed for the inventory and the spell selection menus. So I drew out a font, wrote some code to draw some words, added this piece of test text down here in the level that would stay there for an embarrassingly long time, got some stats rendering to the screen, got an inventory working, and a spell selection menu showing. I also decided after 4 days of work on a wizard game, it was probably a pretty good idea I got started implementing some spells, so I drew a quick little animated fireball sprite, hacked in a particle system, and got our first spell implemented here. And that was all I was able to get done by the end of day 4. Day 5, I started out by trying to implement gameplay, but I got burned again by some bugs. Basically, sometimes when you try to shoot a fireball, either the client or server or both would segfault. And I ended up tracking it down to one of my many tiny networking bugs caused by the functions which had been the bane of my existence for this entire project, N to HS and H to NS, and all of their friends. Let me explain. Basically, when storing data on a computer, let's say a 4-byte integer, you have two options for how you store the bytes. Either you can save the least significant or the most significant byte of data at the lowest memory address. The former is called little endian, and that's probably what the machine you're on is using right now, and the latter is called big endian. And big endian is the standard network byte order. Don't ask me why, this is just how things are. So this means that when sending data out of the network from one computer to another, if we want to build a device-agnostic protocol, which we probably should use the network byte order and flip our bytes if we're sending to or receiving on a little endian machine. If flipping bytes around manually though sounds like something that could get pretty tiresome, don't you worry, because C's got you covered with this family of functions for converting integers from host to network, or H to N byte order, and network to host, or N to H byte order. The suffix just denotes the size of the integer, like S for short, L for long, and these functions are definitely pretty useful, except it's really easy to forget to do this in serialization, or even to use the wrong function since they only differ by 1 or 2 characters, and my beloved C here doesn't warn us about this type conversion that might just chop a bit of our integer off. All that is basically to say that when I was writing my third serialization system in the span of 5 days, and of course not writing any tests for any of it, I forgot to do this conversion somewhere, and the entire system occasionally just decided to blow up. So the first part of day 5 was spent squashing all these bugs by unifying all serialization under one big ol' byte buffer interface like any good programmer would have done from the start. Still didn't have any time to write tests though, but after plugging it in there weren't any errors, so that's good enough for me. With only about 2.5 days left though, I had to actually implement the rest of the game, so I thought it might finally be time that I actually add a bit of gameplay to this, game I was trying to make. So to start, I quickly tripled the size of our spell library by throwing in ice daggers, which are basically just cold and sharp fireballs, and magic missiles that will follow the nearest enemy until they hit them, which we'll be able to test as soon as I add enemies to the game. I also worked a bit on the networking for spells and ended up with 2 packets like this, one that the client sends when it starts casting and one that the client sends when it stops casting, so duration spells can also be added later on. I also threw in this new leveling system for spells where they can have levels 1, 2, 3, 4, 5, and X for the highest level, even though for some reason it's displaying as 0 here. And I divided the spells up into groups based on their aspect like fire and ice, and their category like combat or charm. The UI also got some small updates and new icons as you can see down here, and I added a system for tracking spells casted and leveling the player up based on the number of enemies killed, which will work as soon as the player has some enemies to fight. And that was basically it for day 5. So after realizing that maybe 1 week to implement an entire multiplayer game was possibly just a tiny bit optimistic, I really had to grind out the last couple of days in order to make sure that I could actually finish something worth playing and with the appropriate amount of sorcery. So, since time was running a little thin for any good monsters, I slapped in some zombies by recoloring the player sprites, gave them some A-star pathfinding, and made them damage the player with a little knockback whenever they got close. And to combat our undead friends, I also added a little status effect system so the zombies could get lit on fire or frozen, then I made them drop coins on death. There is still an unfixed bug in there in the status effect system though, where flaming zombies will light their coins on fire before they die, and then when you pick the coins up, they catch you on fire. So gotta be careful about that until I get it fixed. With the poor defenseless little zombies to shoot spells at now, next up I added in a bunch of new ones like duration spells, area spells, projectile bursts, traps, charms like confuse and lock, and buffs like shields and speed boosts. Oh, and also a sound system that I forgot to mention, but I did that one a couple days ago now. Alongside with the little cooldown system that you can see in action down here, which this was also networked to thwart at least a little client cheating, but to be honest I don't really know why I bothered. There are probably so many holes in the protocol that I don't think this is really going to save anyone from even the most mildly determined hacker. After that though, I added in item types with levels, item entities, let the player move them around in their inventory, and also made a way too complicated stats and property system which can let you do things like have a wand that adds an extra projectile to all fire combat spells or a helmet that makes you run faster. All of this too, of course, being networked. I also threw in some little wizard hats, hoods, and cloaks alongside with some armor to give our friend here some extra outfit options and a bit of protection. And now that the player could earn experience and level up, I hacked together a little system with some skill points and some wizardy sounding skills so players can upgrade their stats. And with day 7 wrapping up here, I had to really quickly throw together an endgame, so I made it that if the host's health goes below 0, then the server crashes, so I guess there's an incentive to survive as long as you can. And that's the game, at least what I was able to do in 1 week. Let's do a little post-mortem on this bad boy. Is it a game? Well, technically, yes, so we can check that one off. Mission accomplished, good job. Is it multiplayer? Also yes, definitely working, even though you have to connect on the command line. Is it tested, balanced, stable, bug fixed, or fun? Does it have a main menu? No. So I think I'll just save IGN the trouble and give myself a 2 out of 10 for this one. But if I just stopped there, that would have been a pretty sad end for Sorcery Squad. So allow me to fast forward to the present day and a few more days of work and rapid fire all of the post 1 week changes. The biggest change was a new level generator, which was based on this blog post about how levels are made for Enter the Gungeon, which could really be a video in and of itself, but basically it generates level layouts which look like this based on a connection graph which looks like this. The new levels needed some more things to populate them, so I also threw in enemy spawners, cosmetics like torches and banners, doors between rooms, which maybe in a future version will be unlocked with keys, and I finally let the player escape their one single level and let them move between floors. I also inverted the energy system, so instead of having a limited amount of energy you can cast for, if you cast too much, you might just explode, which seemed like a little more fun. And I also took out the level system because I didn't really like how it worked. And to top it all off, I hacked together a little main menu so that you don't need to connect to servers using the command line anymore, and I added a little lobby level that you could start in and return to if you died. Seemed like more reasonable behavior than just crashing the server. And that's the proof of concept V1 for Sorcery Squad. A pretty fun little project to work on, and something that I'll definitely come back to and give a real release at some point. Maybe also do some, multiplayer playtesting of the multiplayer game. The good news is though, because I spent so much of those 7 days on the engine, it's really capable, so expect big things from Sorcery Squad version 0.0.1b. I've also got a ton of extra AI behavior, enemy sprites, and spell prototypes that I didn't have time to show off here laying around, so hopefully building a V2 of Sorcery Squad will be pretty straightforward. For now, there are some bits of the basic networking code in the description, and I'll post the game on itch as soon as I can figure out how to build it for Windows and Linux. So thanks as always to everyone who supports me on Patreon, especially my very top supporter, Coop. You can head there if you want to download the full source code for this project. And thanks again to Brilliant for sponsoring this video. Be sure to check them out at the link in the description. And be sure to come back next time for either more FPS programming or more wizard antics. Either way, it'll probably be more C code. Thanks for watching.